Okay, we're starting chapter 4, section 2, covalent bonding. Covalent bonding is different than ionic bonding. Recall that ionic, you had a metal ion, which was positive, and a negative ion, which was the nonmetal. Okay, in covalent bonding, we're looking at atoms sharing electrons. The only atoms are going to be atoms of nonmetals. So very few elements are going to be involved in this. So covalent bonds form between two or more nonmetals. Remember, those electrons are sharing between each of the element's atoms. Okay, the number of bonds is going to be based on the number of valence electrons that are needed to get to that magic number of 8, that octet rule. So carbon, which has 4 valence electrons, is going to need 4 bonds so that it can get to the magic number of 8. 4 plus 4 equals 8. Nitrogen, which has 5 valence electrons, can only make 3 bonds. There's no way it can make 4 bonds and be a neutral compound. Oxygen has 6 valence electrons, so it needs 2 electrons, so it can make single and double bonds. And then fluorine has 7 valence electrons, so it can only make 1 valence. It only needs 1 valence electron, so it makes 1 single bond. So a single bond is when there's 1 pair of electrons being shared. That means 1 electron from the fluorine, 1 electron from the hydrogen. A double bond means there's 2 pairs of electrons being shared. So that means 2 electrons from the 1 oxygen are going to bond to the 2 electrons that are singles with the other oxygen. Okay, a triple bond is when nitrogen bonds to another nitrogen. Remember, they already have 5, so when we did that Lewis dot, you notice they had what's called a lone pair. So their 3 single electrons around that nitrogen are going to bond with the 3 others around the others. If you're confused by what I mean, look back at the Lewis dot electron. That video is up. Okay, now when it comes to naming molecular compounds or anything that's covalent, we use numbers to help us identify how many atoms are involved instead of doing the crisscross method. Now, this was not in your reading, so I need you to make sure you get this into your notes. For one of anything, we use mono, but we only use it with oxygen. So if you think of 1 carbon bonding to 1 oxygen, meaning it has not done 4 bonds like carbon monoxide, that means 1 carbon, 1 oxygen, and it's not a complete gas, which is why it's poisonous. Carbon dioxide, that di tells us there's 2 oxygens. So that 2 oxygens are each making a double bond to 1 carbon. If we have a tri of something, like nitrogen trihydride, means you have 3 hydrogens, each one making a single bond with the nitrogen. Tetra is 4, penta is 5, like a pentagon has 5 sides. Okay, hexa for 6, hepta for 7, octa for 8, like an octagon, nona or nana, I'm not sure how they pronounce it, for 9, and deca for 10, like a decade is 10 years. Make sure you get all of those down. If you need to, stop, write them down, and start up again. All right, when we look at the properties of molecular compounds, they're going to be weaker or lower than an ionic compound. Ionic compounds have really strong forces. It takes a lot of energy to break them apart. Molecular compounds are weaker. If it helps you to think of it, sugar is a molecular compound. And if you've ever made caramel sauce or anything else where you have to put a little sugar in a pan and melt it on a stovetop, you notice it melts pretty well. It has a lower melting point than ionic, so that means it's going to change to a liquid at a lower temperature. It has a lower boiling point than an ionic compound, so that means it's going to change to the gas phase at a lower temperature than ionic compounds. And then they're poor conductors of heat and electricity, meaning the electrons are not likely to move easily. So we call molecular compounds insulators. So think the styrofoam cup that you might hold hot chocolate in that insulates your hands from getting a burn. Now, sometimes the electrons share nicely and sometimes they do not. So we need to know when that's going to happen. So when some atoms pull more strongly than other atoms, we call this a polar bond, like there's a pull. So if you think of tug of war, one side pulls harder and knocks the people into the mud. That's how one side of the atoms pull the electrons more often to hang out with them. When hydrogen bonds to oxygen to make water, because water has two lone pairs on it and only needs to make two bonds, it has a lot of negative energy all on its own. It pulls hydrogen atoms, those electrons, closer to the oxygen electrons to hang out, so there's an unequal sharing with a water molecule. Now, when things share equally, we call it a nonpolar bond. So when carbon is bonding to each oxygen with a double bond in carbon dioxide, it's an equal sharing of the electrons between the oxygens to the carbon. So that's a nonpolar bond. There's no pull on the bond. These attractions between the molecules leads to different properties. Polar covalent bonds are stronger than nonpolar covalent bonds. So when you have polar opposites, so if we put something into water, we use water as the main component of our solution, and we put something in there, polar covalent compounds and ionic compounds will be attracted to the opposite sides of the water molecule. So anything that has a positive ion or has a little more positive pull to it is going to be attracted to the negative ion part or the oxygen end of the water molecule. Something that has an equal pull is not going to be interested in hanging out with water. So in the picture here, we show salt being dissolved into their sodium and chlorine ions. You notice that the chlorine ion, that green thing, has the hydrogen side of the water molecule because that doesn't have the electrons around it as often, attracted more to that chlorine ion because that chlorine ion has the extra electron with it. The sodium component has given up its electron to the chlorine, so it's attracted to that oxygen end of the water molecule, and that's represented by the red part of the water molecule. So they're going to hang out. They're not going to bond together. They're just hanging out together, and each of those ions are going to be encircled by that part of the water molecule that's kind of the opposite. Okay? Now what I'm showing you here is actually like a soap molecule. What they call the hydrophobic group, the water-hating part, that's nonpolar. Okay? That's going to get any dirt or whatever part to cling to it because it's all kind of nonpolar. And the ionic end, that sodium ion part with that like grayish colored circle, that's the water-loving head. That's going to pull everything towards the water so it can be washed away in the water. Okay? So this is literally what a soap molecule or a detergent molecule looks like and how it can pull dirt and grease and grime off clothing, off your hands, whatever, to get rid of all the nasty stuff in the water. It's not the water that's doing it, so you're told to wash your hands in warm water with soap. That's so that it's comfortable. You can wash your water in cold water and still have stuff happen. You're just not going to wash as long because no one wants to hang out in cold water. Okay, so the attraction between molecules, when you have nonpolar compounds, they will not mix with polar compounds. So remember, likes dissolve likes. So my examples, oil and water, oil and vinegar. If you've ever seen a bottle of Italian salad dressing, you know that you have to shake it up to mix the components. Otherwise, they layer and the oil will lay on top of the vinegar. Okay? When something is polar and it mixes with polar, then it's mixed well. All right, so remember that likes dissolve likes. We're going to hear that a couple times. All right, so in this section, the first question wanted to know, how do the valence electrons, what do they do with the atoms? And they're shared by the two atoms. When we have atoms becoming slightly negative or positive by the pulling, we call that an unequal sharing. Attractions between polar molecules are stronger than nonpolar because they have more energy, and they need more energy to kind of break their bonds. And then covalent bonds share electrons. Ionic bonds are transfer. They wanted to know what's the difference between them. All right, that's it. Make sure you understand this. If you have questions, email me.